today we are going to finish our talk about like how to take the derivative of things. Um, for the past couple months, yeah, for the past couple months, we've been going very slowly over, okay, well, here's how you take the derivative of this situation. Here's how you take the derivative in this situation, this situation, this situation. Today's the last situation. Um, Anything after this is going to be basically, all right, we have our basic toolkit. Now we're going to sort of venture out into the world and play around a little bit. So what are we doing today? We're going to be taking the derivative of an inverse trig function. And how are we going to do this? We're going to use the model that we have. There's ways to prove it, and I even think like in the homework, they'll guide you through where the derivative comes from and how to get it. But honestly, you're almost better off memorizing them. And I hate to say that because I am very fastidiously not a memorizer. I hate memorizing. But these are different. They're not like intuitive. Like you can't go and show why it is as easily. Um but we're going to go through and we're going to talk about it. We're going to get comfortable with it. We're going to get familiar with it. On this next page, I actually have two different ways of writing the exact same thing. I put them both here because you may prefer to look at it one way versus the other, um, or some combination of the two. Or some combination of the two. But it's up to you. I just want to present you with all the possibilities here. So here we have inverse sine, inverse cosine, inverse tangent, cotangent, secant, and cosecant. And I just have it written two different ways. You'll notice they basically look the same. This one is written with sort of the inverse being the -1 notation, whereas this one's written instead of it being the -1 for the inverse, they use arc sine, arc cosine, arc tangent, and so on. Me personally, when it comes to notation, I am a bigger fan of using arc sine, arc cosine, and all of that because the -1 can leave you feeling like you're working with an exponent, and that doesn't work so well. And then in addition, thank you for updating directly in the middle of my lecture and changing the screen on me ad block for like, hey, I updated. Why'd you didn't need to do that? Okay, so but on the other hand, I don't really like the U prime notation that this one uses. I much prefer the du dx notation that they have here. But it's still the same thing. You like one, you like the other, you do the correct math, it's going to be the same work. But basically, the way that it goes is, you figure out what's on the inside of the arc trig function, and then you take the derivative of that. That goes on the top, along with potentially a negative sign. Along with potentially a negative sign, and then on the bottom there's a thing, and it's basically boils down to one of three things. It's either square root of 1 minus u squared, a 1 plus u squared, or the square root with the absolute value in there. All right. So let's go over some problems, and basically we're just gonna sort of work through this. We're just gonna work through this. I've got just a whole bunch of examples. So if you look, we're trying to figure out the derivative of arc cosine. So let's go back. The derivative of arc cosine is negative 1 over the square root of 1 minus u squared times the derivative of u. So let me write that down over here. And think about it kind of like when we were first learning how to do it, do the chain rule. We made our u, we made our du. This is slightly akimbo because my tablet's not right. Made our u, we made our du. 7 times 6 is 42. X to the fifth. And then it was negative, and then the radical with the 1 minus u squared. So we got and we're just going to u squared. So u is 7x to the 6th. So this is 49x to the 12th times du, 42x to the 5th. And that's what we get. And we can make it pretty, make it simple. And we can make it simple. And this is our answer here. But you don't have to do anything more than this. Don't try and do anything else fancy. There's no need. Let's do the next one now. Here's cosecant, and they do in situations where there's a potential issue with like domain and range, where like we can't have this thing on the inside less than 1. So they give you that. And then what we're doing? We're doing cosecant. Let's look at cosecant. Cosecant is this one. So we've got -1 on top, absolute value of u, radical u squared minus 1. So I'm going to... Oh, I went one too far. Oops. Let's do this one first because it's there. Secant. Same thing as cosecant, just a plus instead of a minus, right? A -1 on top for cosecant, a +1 on top for secant. And that should sort of be expected. Remember that when we take the derivative of cosine things, we end up with a negative number. When we take the derivative of sine, secant, and tangent, we got positive things, right? So, okay, secant 1 over absolute value u times radical u squared minus 1. Right? So now, okay, what's u? U is 4s to the 5th plus 9 du 5 bring down, we got 20s to the 4th. Now we just put it all in. So this is the frame. dy ds is going to be 1 over the absolute value of 4s to the 5th. Oof, this looks really bad. Let me make it bigger so that my handwriting isn't. The absolute value of 4s to the 5th plus 9 times the square root of 4s to the 5th plus 9, the quantity squared, minus 1. And then times the derivative, which is times 20s to the 4th. And then again, if you want to make it nice and pretty, you can put this on top, this on bottom. For s to the 5th plus 9 squared minus 1. Yeah, and then here's that. This is a times sign. Yeah? So the only part that isn't just straight up copying things into a form is identifying u, identifying du, and then that's it. So don't overthink this. Honestly, it's not that it's difficult to do the problem itself. The problem Mr. Webster personally has is remembering which one of these is which. That's my problem. That's the problem I've always had because I cannot memorize my way out of a wet paper bag. I can't. It's just how I've been. All right. Cosecant. Same idea. Let's do this part first. We've got our u. We've got our du dx. And I did want to point out, I specifically copied these directions because I think maybe sometimes they'll look and you'll overthink. Find the derivative of y with respect to x. That is literally just saying the derivative of y with respect to x. So we're just trying to find the derivative, so dy dx. Don't overthink that one. Right, and then the derivative of this inside is 8x. And then, if I remember correctly, the only difference between what we just did and what we're about to do is that there's a negative sign on top. I'm going to go back and double check because I'm not 100% sure because, again, my memorization skills are very bad. So that should technically be times 8x up here. That should technically be right. I'm going to go back and double check just to make sure. -1. Yeah, good. Hey. And once again, go ahead and take the time to make it nice and pretty. If you like, -8x over this madness for x squared plus 1 times the square root of yeah, and there it is. All right, next one. So now here we're having to do multiple things. Natural log of tangent inverse of. So let's take it one step at a time because this requires us to have chain rule. So remember, natural log du over u. So let's figure out what du is. We've got our u is just this tangent -1. The hard part's what's going to be on top, right? So we've got inverse tangent of 5x to the fourth here on bottom times the derivative of that thing on top. All right, so let's go back and look at the tangent one. I think it's du over 1 plus u squared. Hey, I was right. Yay. Okay. I can be taught. So now we're going to take du 20x cubed over 1 plus u squared like that. So this technically all would go in the numerator, but like remember, if there's a denominator and a numerator, you can just take that and throw it down to the denominator. So I can just rewrite it and multiply the tops here and multiply the bottoms here and get 20x cubed times tangent inverse of 5x to the fourth times 1 plus, and then I'm going to square this. 5 squared is 25. X to the fourth squared is x to the eighth. And voila, I am finished. And again, there's no need to do any more with that. There's no simplification that can be done. So just leave this as it is. All right. 2 more. Cosecant. Oh, we did a cosecant one already. Cosecant, remember the form looks like negative du over absolute value of u times the square root of u squared minus 1, I think. Yeah. Hey, I'm remembering things. Hooray. Okay. So now I want to find the derivative of y with respect to t. That is to say, I just want to take the derivative and let t be my. So look, what's u is e to the 6t. What's du is 6e to the 6t. So look, on top, dy dt is negative du over absolute value of u times the square root of u squared minus 1. And everybody see how u squared, e to the 6t squared, that's e to the 12t, right? Remember, exponent to an exponent, you multiply the exponents. And that's it. So once again, they give you your domain. You don't have to worry about this so much. But here, as you're doing this, just remember you're doing 2 separate problems. Don't try and overthink this. You're doing 2 separate problems. Just do them separately and then just put a plus sign in between them at the bottom. So we got u over 1 plus, du over 1 plus u squared for tangent, negative 1 over absolute value of u times radical u squared minus 1 du up top. So let's do two separate problems. Again, we're just going to do these two separate problems. We're going to do the tangent one, we're going to do the cosecant one, and then at the very end, we're just going to put a plus sign in between them and be done for the day, right? So let's do this. We've got our du is 18x, right? Our u was the 9x squared minus 1. So let's put all that to work here. We've got 18x over 1 plus 9x squared minus 1 squared. There's that. And then let's do this part. Cosecant. Well, what's our u is 3x. Our du is 3. So we've got negative 3 over absolute value of 3x times the square root of 3x squared, 9 times x squared minus 1. There's our two pieces. Now let's just make our final answer. And let's make that a minus sign since this is minus. 3x, that's the absolute value. Try that again, make it look better. 3x times the square root of 9x squared minus 1. Yeah. And that's all.